The other day we worked with multiplying and dividing rational expressions or fractions. Today we're going to do some adding and subtracting and then some compound fractions. So when we are adding or subtracting, we need a common denominator. And you got to be careful because you may say that these two denominators are the same, but they're not. One is x minus 5 and the other is 5 minus x. So in order to make them both the same, we can multiply this one by -1 over -1. And then that gives us 2x over x minus 5 minus -5 over, and this becomes -5 plus x. And then I'm going to rearrange that so it looks exactly like the first one. So then we have 2x over x minus 5 minus -5 over x minus 5. Well, minus the negative means adding, so 2x plus 5 over x minus 5 is our simplified radical expression. All right, number 2. Right now it doesn't look very nice, so we're going to factor both denominators. So the first denominator becomes x plus 2 times x minus 1 minus 2 over, this becomes x minus 3 times x plus 2. So if we look at both of these denominators, they have an x plus 2 already. But for them to be exactly the same, we're going to have to multiply this first fraction by x minus 3 over x minus 3. And then we're going to multiply the second fraction by x minus 1 over x minus 1. And now we're not going to multiply out that denominator. We're going to leave it all in factored form. But the numerators we are going to distribute. So the first fraction, distribute the x minus 3 into the x. That becomes x squared minus 3x. And then the second fraction becomes 2x minus 2. Now remember there's this minus sign here, and then it's being distributed. So we're going to have to distribute that negative sign at some point. All over the common denominator, which in factored form is x minus 3 times x plus 2 times x minus 1. So now we're going to simplify the numerator. We have no other x squared, so it's going to be x squared. Then we have -3x minus 2x, which is -5x. And then we have nothing minus -2, which is going to be +2, over my factored form. Now, we would want to see if we can factor the numerator, x squared minus 5x plus 2. If we can factor that, then maybe we can cancel something from the numerator and denominator, but we're unable to do that. So this is our simplified answer. Here, we have 2 over x plus 1 plus 2 over x minus 1 plus 1 over x minus 1 times x plus 1, because we factored that. So if we look at the denominators, the first one has an x plus 1, the second fraction is an x minus 1, and the last fraction has them both. So we don't need to do anything with that fraction. What we can do is multiply the first one by x minus 1 over x minus 1, and we can multiply the second one by x plus 1 over x plus 1. So again, we're going to distribute the numerator. So we're going to get 2x minus 2 plus 2x plus 2 plus 1, because again we distribute this, plus sign, distribute that, plus sign 1. All over our common denominator of x minus 1 times x plus 1. So that numerator, we want to combine our like terms. We have 2x plus 2x, so that's 4x. And then we have negative 2 plus 1, which is 1, all over x minus 1 times x plus 1. And again, if we could factor the numerator to cancel something out, we would do that. But in this instance, we cannot do that. All right, in problem number 1, we can rewrite this 1 by multiplying the top and bottom by x plus 1. That way the denominators of the top fraction match. And then down here, we can also multiply the top and bottom by x plus 1. So then, once we distribute all this, we're going to have x plus 1 plus x, because we have plus x right here, over our common denominator of x plus 1. And then the second fraction, distribute that again, is going to be x plus 1 minus x over x plus 1. So now I have a fraction over a fraction. I'm going to combine like terms, and then instead of dividing, we're going to multiply by the reciprocal. So in the light blue, we have x. We have x plus 1 plus x, so that's going to be 2x plus 1 over x plus 1. And then the other fraction, we got to flip it, so we have x plus 1 over x plus 1 minus x is just 1. Well, we have an x plus 1 factor in the numerator and denominator. So this is now going to be 2x plus 1 over 1. And we know we don't need to write over 1. So our answer is 2x plus 1. And then number 2, all right, our top fraction, we have 5 over y minus 6 over 2y, and then our bottom fraction is 5 over y plus 4. So if we multiply the first fraction in the numerator by 2y plus 1 over 2y plus 1, we then can multiply the second fraction by y over y. So my numerator is going to be 10y plus 5 minus 6, because the second fraction is 6, and then times y, so minus 6y, over our common denominator of y times 2y plus 1. Over, this one isn't as bad because we just have to multiply the 4 by y over y, because that will then give us 5 plus 4y over y. So now we can combine our like terms and then multiply by our reciprocal. Our top fraction, 10y plus 5 minus 6y over y times 2y plus 1, is going to be 4y plus 5 over y times 2y plus 1. And then we're going to take that second fraction and flip it, so y over, and I'm going to rewrite the order of that. So then what you're going to see is that the 4y's plus 5 cancel, and y over y cancel. So we're really left with 1 over 2y plus 1. Now, if you were ever asked about the domain of this, you would have to go, again, back to the original function and see what values y could or couldn't be. But the directions didn't say anything about domain, so we can leave it just like this. All right, on to the next page. Here, we're going to multiply the first fraction by y over y, and the second one by x over x. This is going to give us y minus x over xy over, we can do the same thing in the denominator, so we have x plus y, or y plus x, it doesn't matter, over xy. Now, a shortcut from here is you could say, well, the denominators of both of these fractions within the fraction are just xy, so can we just cancel them out? Yes, you're going to see that those will cancel out when we multiply by the reciprocal. So we're going to have y minus x over xy times the second fraction flipped, and yes, you can see that the xy's cancel, and that's going to give us y minus x over x plus y. And again, because we can do addition in a different order, the numerator could be negative x plus y if you wanted to do that, but this is perfectly acceptable as well. So much easier than the problem initially looked. All right, now the last one here, we don't have to do anything with the bottom fraction, but the top of this fraction we have to get our like terms. So x plus 1 over x plus 1 times x over x. So then our numerator is going to be, when we distribute this, x plus 1, and then minus 1 times x, so minus x, over our common denominator of x times x plus 1. And like I said, our denominator of our big fraction only has one fraction, so we can just bring that down. So let's clean this up a little bit. Combine like terms, we have x plus 1 minus x, so x minus x is 0. So we have 1 over x times x plus 1 times, we'll flip the second fraction, x plus 1 over 1. Well, again, our x plus 1s will cancel. So our simplified answer is just 1 over x. So looking at each of these fractions individually will help us simplify them and then multiply by the reciprocal later. So each one of these complex fractions is just like a mini one of these problems from up here. So hopefully that made a little bit of sense and we're able to go a little bit further now. So thanks for watching. Make sure to smash the like button and subscribe.